Okay, so homework problems 14 through 19 all use the f of x here at the top. So I'm going to just put it all in one video and go straight through. Number 14 says select all of the following that are the zeros of the function. We looked at zeros before. We know zeros are where the equation crosses the x-axis. We are able to solve for them by making our f of x or our y equal to 0. So I'm going to say 0 equals x squared plus 8x plus 12 and x minus 2. Our first goal is to always set the factors equal to 0. So x squared plus 8x plus 12, everything in that one set of parentheses is a factor. So I'm going to set all that equal to 0. And then I set my other factor, x minus 2, equal to 0. This one's easy to solve. I just add 2 to the other side. X equals 2. Since it's a solution, it is an x-intercept, so it's going to be 2, 0, which is E. So I circle E. This one, you can do it two ways. You can use your quadratic formula, or you can just factor. I'm just going to factor it because it's an easy one to factor. My A is 1, my C is 12, so 1 times 12 is 12. So two factors that multiply together to be 12, but add together to be 8. Those two numbers are 6 and 2. So instead of writing 8x, I'm going to write x squared plus 6x plus 2x plus 12 equals 0. I now have four terms. I'm going to group my first two together, my last two together. My greatest common factor here is x, so I'm going to divide everything by x. X squared divided by x just leaves it as x. 6x divided by x is 6. I have positive 2x and a 12. I can divide both by a positive 2, leaving x plus 6 equals 0. My two insides are the same. Fantastic. So now it's x plus 6. X plus 2 equals 0. I can now set both of these factors equal to 0. Now I just solve for x. X equals negative 6, so negative 6, 0, which is D. Subtract 2, subtract 2, x equals negative 2, negative 2, 0, which is A. So those are my three solutions to the function x squared plus 8x plus 12 times x minus 2. It's going to cross the x-axis 3 times. Number 15 says, which of the following is equivalent to f of x? So if you look, it has an x cubed here. So if I'm looking at the original, I can tell x squared times x is x cubed. So my clue is that I'm just going to distribute everything in this first set of parentheses to everything in the second. So let's get a cleaner piece of paper. So I'm going to start at the beginning. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Now I move into this middle term. 8x times x is 8x squared. 8x times negative 2 is negative 16x. And then my last two, 12 times x is 12x. 12 times negative 2 is negative 24. Okay, now I'm just going to combine my like terms. X cubed gets rewritten. It doesn't have any like terms in the function. Negative 2x squared and 8x squared makes it a positive 6x squared. Now negative 16x and 12x makes it a negative 4x minus 24. Now those are all, my like terms are all combined, so that's how it simplifies. So now I can look, and it's not the first, it is my second answer, which is B. The third question, number 16, says the function g of x equals f of x plus 20. Which of the following describes how the graph of g of x is different from f of x? So I look at my answers. It says f of x is shifted left 20 units to create g of x, shifted right 20 units, shifted down 20 units, and shifted up 20 units. This should remind you of what we did with quadratics when we were shifting them from their parent function left, right, up, and down. It's exactly like that. It works the same exact way. Since that add 20 is outside the parentheses of the x, we know the function is moving up 20 because it's a positive 20, so it's going up 20. So f of x is shifted up 20 units. What I mean that it's outside the parentheses, if this is what the question said instead, that the x is on the plus 20 is on the inside of the parentheses connected to x, that means it would be left, because remember the sign is different. The positive means move left, left 20. But here, since the 20 is on the outside, it's shifted up 20 units to create the new function. All right, so now 17, we're building even more. We're using the function g of x and f of x described above. Select all the following that are true. So they want to say when we plug in 1 for g of x and 1 for f, which value would be greater? Now let's think about it. If g of x is always going to be 20 more than f of x, we know our g of any number will always be bigger than our f of x. So I look at my answers and I see g of 3 greater than, so I'm looking for the greater than symbol to tell me that g of a number will be greater than f of a number, and this one also means that. If you were confused or you don't really know what it means, let's look at B. Let's actually do the math. We're plugging in 3 for our x. So if I jump up to here, since it's equivalent, I know my f of x equals x cubed plus 6x squared minus 4x minus 24. And I am going to plug in 3 for my x. So now it's 3 cubed plus 6 times 3 squared minus 4 times 3 minus 24. 3 cubed is 27 plus 6 times 9 minus 12 minus 24. 27 plus 54 minus 12 minus 24. I'm going to plug all that into my calculator. I am going to say 27 plus 54 minus 12 minus 24, and that is 45. So f of x equals 45. Now g of x equals f of x plus 20. So g of x, or g of 3, would be 45 plus 20, which is 65. Now, isn't 65 greater than 45? So that's why my g of 3 is greater than my f of 3. And any of my g's should be greater than my f's. Now, if I look at 18, 18 says the function h of x equals negative 3 times f of x. The graph of f of x has a maximum at negative 4.3, 24.6. What will occur at x equals negative 4.3 on h of x? So let's think about it as a quadratic, since that's what you guys are most familiar with. Since the graph of x, f of x has a maximum at this, that means the vertex is the very highest point. Now, if I were to multiply f of x by negative 3, that means that graph is going to flip the opposite direction since it's a negative 3, which then makes it go like this. Now my vertex is a minimum. So I am going to cancel or get rid of B and D. Okay, so since we know we can get rid of the maximums, we know our vertex would be a minimum. Now we just got to figure out what the y value would be when you multiply it by negative 3. So since we know our original function has a maximum at negative 4.3, 24.6, I can multiply this by negative 3 to get the new y value for my h of x function. And I can even just look at my two answers. There's one positive and there's one negative. So positive 24.6 times a negative 3 would make it a negative 73.8. So my answer is A. Okay, so number 19 says using the function f of x described in the table to the right, and given that j of x equals negative 3 times f of x, select all the following that are true. So what that means is I'm going to add another part to this table so I can figure out what j of x is. I know j of x is whatever f of x is times negative 3. So 0 times negative 3 is just 0. Negative 15 times negative 3 is 45. And then negative 24 times 0, or negative 24 times negative 3 is 72. Negative 21 times 3 is 63. 0 times negative 3 is just 0. And 45 times negative 3 is negative 135. I can now look. J of 1. J of 1 is 63. Is 63 less than negative 21? Nope. J of 3 is negative 135. Is negative 135 less than 45? Yep. J of negative 2 is 0. Is 0 less than 0? No. J of 0 is 72. Is 72 less than negative 24? No. And J of 2? 0 equals 0? Yes. So those are my answers for numbers 14 through 19.